video, I'm going to show you an example of how you multiply matrices. All right, I've got two matrices to work with, and I'm going to remind you that the first thing you have to think about is, do the matrices have dimensions that are compatible to each other? Here's what I mean. Matrix A has dimensions 2 by 2. Matrix B is a 3 by 2. Remember, we name the matrices, or we identify their dimensions by how many rows they have compared to how many columns they have. So matrix B has 3 rows and 2 columns. All right, the first thing I'm going to ask you to think about is, can I multiply A times B? Well, here's how I make my decision. I look at the dimensions of matrix A, I look at the dimensions of matrix B, and I ask myself, do the two inside dimensions, do the number of columns of the first matrix equal the number of rows of the second matrix? If these two dimensions are the same, then you can multiply the two together. If they are not, then you cannot, or we say this matrix product is undefined, or we can say there's a dimension mismatch and so therefore it cannot be done. So let's try going the other way around. B times A. Order matters for multiplication. I might not be able to multiply in the order A times B, but I can multiply B times A. Let's double check. And by the way, I like to write my matrices side by side. So if I'm going to be multiplying B times A, then I'm going to rewrite A over here next to B so I can compare their dimensions. A is a 2 by 2, 2 by 2. And like I said a couple minutes ago, we're going to check to see if the inside dimensions match. Since the 2's match, then yes, I can multiply, but probably a bigger point is the fact that the outside dimensions, this one and this one, determine what our product will look like. So 3 by 2 are what are going to be the dimensions of our product matrix. So here I go. My product matrix is going to be a 3 by 2, 3 rows, 2 columns. I know I'm making it extra big, but there's a reason I'm doing that. 3 rows and 2 columns. I'm drawing lines just to bring my attention to where I'm going to be writing numbers. It's helpful for me to see that. Okay, so if I'm multiplying B times A, I'm going to take, let me grab another pen, another color. I'm going to take the first row of matrix B, and I'm going to multiply it by the first column of matrix A, and that number is going to go in this spot. Now, I use that loosely, that number. How I get that number goes like this. I'm going to multiply the first number times the first number, so negative 3 times 5. Then I'm going to add it to 1 times 0. So I'm going to write it right here, just like I said it. Negative 3 times 5 is a negative 15, and I'm going to add it to 1 times 0. And that's how you complete the first row, first column. So think ahead. What will the first row, this number right here, first row, second column will go right here. So first row, second column. Negative 3 times 1 is negative 3. You're going to be adding it to 1 times 2. Keep going in that same fashion and complete each row, each column of your product matrix. So I'm going to go to the second row now. Since I'm in the second row, multiply the second row times the first column. 2 times 5 is 10. I'm going to add that to negative 4 times 0. And then second row, second column. 2 times 1 is 2. Plus, I always write a plus regardless of what I'm going to be writing next, because I know I'm adding or combining the two numbers together. Negative 4 times 2 is a negative 8. And then lastly, third row, negative 1 times 5 is a negative 5. 5 times 0, 0. Last one, third row, second column, negative 1 times 1, plus 5 times 2, 10. Then I'm going to simplify and say that my product matrix will be negative 15 plus 0, which is a negative 15, negative 3 plus 2, which is a negative 1, 10 plus 0, 2 plus a negative 8, negative 5 plus 0, and then negative 1 plus 10. This right here represents the product of B times A.